Okay, now the real work begins, because we're doing work. Alright, so work energy theorem worksheet. Let's start with number 1, and maybe we'll do 2 also, I don't know. Okay, so a toy car with a mass of 2 kilograms starts at rest. A spring performs 196 joules of work on the car. What is the toy car's final velocity? Awesome, they give us a lot of stuff, so I'm going to start writing in the question before I write the stuff off to the side. So I see my mass of this, see the mass. I see it starts, see this is also important, it starts at rest. So that means its initial like kinetic energy, stuff like that, is probably going to be 0, right? A spring performs 196 joules of work, so we have work. So we have mass equals 2 kilograms. We have initial kinetic energy equals 0, right? We also have work equals 196. So you see, it gives us a lot of stuff in this one, which is awesome, because that means that's less work we have to do, right? Meh. Alright, so let's do our formula. So what is a toy car's final velocity? So this is like, crap, what formula did I use? There's so many formulas of velocity. Well, remember, we're on work energy theorem, so it's the formula for work. So our formula for work, I'm going to write a bunch of stuff. It's going to be redundant, but that's okay. Equals your final kinetic energy minus your initial kinetic energy, right? Now let's break it down. Your work equals 1/2, because we know kinetic energy, I'm going to put a line here, so it's 1/2 times mass times your final velocity squared. We know that since it wants us to find that, we're not going to have this, right? That makes sense. Minus 1/2 your mass times your initial velocity squared. Okay, so now let's plug stuff in that we know. We know work. It performs this much work. So let's go 196 for work equals 1/2. What's our mass? 2. What's our final velocity? We don't know. What's our final velocity squared? Minus our initial kinetic energy. Well, remember, it started at rest. So that means you can put this stuff here and then put 0 for your initial velocity, and then it ends up being 0. Or we can just start it at 0 right now. So that's what I'm going to do. I'm just going to start it at 0 because that's the easy way. Okay. So now this is actually a really, really easy one, because let's look at this. 196 equals 1/2 times 2. Well, 1/2 times 2 is what? It's just 1, right? And then you're going to have 1 times final velocity squared, which 1 doesn't matter in this case. So I'm going to go over here. I'm going to put 196 equals final velocity squared, right? Because, again, we don't really need to put the 1 there because there's a 1 there anyways. And then we don't need to put minus 0. Let's kind of section this off. There we go. So we started here, step 2, step 3, we're at step 4. So we have 196 equals final velocity squared. Awesome. How do we get rid of final velocity squared? How do we get rid of a squared variable? Well, we square root it. And that means we got to square root this side. So the square root of a variable squared is just a variable, right? So we have our final velocity equals, now we got to do the square root of 196. So punch that in. Hopefully you guys got that. 14 meters per second. Awesome. Pretty easy, right? Okay, let's go ahead and do number 2. We're on a roll. Let's set up number 2. Okay. So a wagon with initial velocity of this and a mass of this gets a push of this many joules. What is the wagon's final velocity? Okay, so we have initial velocity, 4 meters per second. We have mass, 35 kilograms. We have work, capital W, 350 joules. Awesome. Cool. So if you want to get like extra crazy, you can do, and I'm going to work this out anyways, but you can be like, well, if I have initial velocity and I have mass, I know, because I know it's we're using the same formula for work. So work equals kinetic energy final minus kinetic energy initial. Well, if they gave me initial velocity, and I have mass, I have everything I need to solve this. So I can just start off the bat and be like, yo, kinetic energy initial equals, and then I'll have to do 1/2 times mass times velocity squared. So if you do that straight off the bat, you're already done. So 1/2 times 35 times 4 squared, let's see, 280. Hopefully I got that right. So now look at all the stuff we've just done. Boom, 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 boom. We have almost everything we need in this problem. So at this point it's like, I mean, heck, it's probably like 80% done. Now we're just plugging stuff in. So work, which is 350, equals our final kinetic energy, 1/2 times our mass. We have our mass off to the side because we did it at the beginning, 35, times our final velocity. Well, they're asking for final velocity, so we know we're not going to have that. Times final velocity squared, minus, we've already solved this because we did it at the very beginning, so we can just put 280 here. Dang, I said I wasn't going to do it, and I did it. Did the whole problem. Okay, so at this point, we can pretty much do our basic algebra stuff. So let's see. We have this minus 180, so let's just bring this over. Plus, or sorry, not 180, 280. Plus 280, plus 280. So that's gone. So let's see, 350 plus 280, let's see, 630. Is that right? Yeah, 630. So we have 630 equals 1/2 times 35 times final velocity squared. Okay, cool. So now we just got to do this. 1/2 times 35, 17.5. So we have, arrow it up here. Make my arrow nice and pretty. Awesome. So we have 630 equals 17.5 final velocity squared. So we have 17.5 times final velocity, right? So since it's multiplying, we gotta make it 1, so divide by 17.5. Divide by 17.5. So now I'm gonna flip it because I like the variable on the left. Final velocity squared equals 630 divided by 17.5. I think that's 36, so I'm going to YOLO, say it's 36. Ooh, this is awesome. This is awesome. Why is it awesome? Because we know we're going to have to square root this, and this is a good perfect square. So we got to square root this to get rid of this little 2 here. I want it gone. Gone. Which means we got to square root that. So our final answer is final velocity equals, well, the square root of 36. Hopefully you can do it in your head, because you know if it's a perfect square, the number comes out. So it's 6. So meters per second. Awesome. We did it. That's it. So that's that'll help you. 3 and 4, they're all similar questions. You know, 3 instead of the final velocity, it asks for the initial velocity, and 4 pretty much asks for the final velocity again. I want to say, yeah. So cool. Good job, guys.